must have. Second, any model that described the whole universe in detail would be much too complicated mathematically for us to be able to calculate exact predictions. One therefore has to make simplifying assumptions and approximations, and even then, the problem of extracting predictions remains a formidable one. Each history in the sum over histories will describe not only the space time but everything in it as well, including any complicated organisms like human beings who can observe the history of the universe. So, this might be related to what you were asking a moment ago. Um, Useless, toothless, because pretty much human beings do care about this stuff. It gives us some purpose. Some of us do like to understand how this universe got started, and understanding cosmology is important to us. It gives us a certain sense of purpose. It's sort of that the reason for all of this is because we're curious. It's the inquisitiveness and exploratory nature of the mind that makes it imperative that we sometimes study these types of things, and a lot of people care about understanding these things. So now, it is true that if you don't care, then that's also fine. The universe will exist nonetheless, for sure. And the concept of time that you were asking about too, in this context, it's sort of part of this four space-time mathematics. So that's really the definition of, that's really the context of it. In general, if you don't measure the time and you don't care about it, then that's totally a fine way to live as well. Fine way to live as well. So, and in fact, time is relative. So, indeed, the measurement of time as far as how much time has passed, that is relative depending on what you're, depending on your frame of reference, and depending on which of, which massive body you're close to, because a massive object will bend space and time. So measurement of time as far as how much time has passed, that question that you asked, that's the context of time in that sense. Time dilation, relativity making time different depending on your reference frame. But this time that we're talking about in the sense of space-time, geodesic, metric, general theory of relativity, quantum gravity, the dimensions that you need to set up the math for all this, that time is which is a little bit different as we find here in relativity versus quantum gravity, because in quantum we allow the imaginary time in the math as well. So that time is not so much about measuring clock time. It is, time is given the status of a dimension in the geometry. Okay, so all right, so then any model that described the whole universe in detail would be much too complicated mathematically for us to be able to calculate exact predictions. One therefore has to make simplifying assumptions and approximations, and even then, the problem of extracting predictions remains a formidable one. Each history in the sum over histories will describe not only the space-time but everything in it as well, including any complicated organisms like human beings who can observe the history of the universe. This may provide another justification for the anthropic principle, for if all the histories are possible, then so long as we exist in one of the histories, we may use the anthropic principle to explain why the universe is found to be the way it is. Exactly what meaning can be attached to the other histories in which we do not exist is not clear. This view of a quantum theory of gravity would be much more satisfactory. However, if one could show that using the sum over histories, our universe is not just one of the possible histories, but one of the most probable ones, To do this, we must perform the sum over histories for all